The first alert came from the edge. 5xx errors increasing at API gateway, then another. Request throttling detected. Slack lit up almost instantly. Users reporting failed requests. Seeing 429 and 503 responses. Is the backend down? I opened Grafana. Request rate was climbing, but not dramatically. What stood out was rejection rate, spiking fast. Not latency, not CPU. Requests were being dropped before they even reached the services. That's when I realized the system wasn't slow. It was refusing traffic. Environment context. We were running on AWS. Global traffic routed through CloudFront, then into an API gateway layer. From there, requests were forwarded to an EKS cluster in US East 1. About 80 microservices behind the gateway. Traffic averaged around 3K requests per second. During peak, we expected up to 8K. API gateway handled authentication, routing, and rate limiting. Backend services were healthy. Kubernetes autoscaling was configured. Databases included RDS PostgreSQL and DynamoDB. Monitoring stack included Prometheus, Grafana, and CloudWatch. From a design perspective, the gateway was the front door. Everything passed through it, which meant if it failed, nothing else mattered. Initial symptoms. Users reported intermittent failures. Some requests worked, others failed instantly. No delay, just rejection. 429, too many requests. 503, service unavailable. From the back end, everything looked normal. Pods were running. CPU usage was moderate. No spikes in error rates internally. Database was stable, which made it confusing, because the system behind the gateway was fine, but users could not reach it. Investigation and escalation. First thought was rate limiting. Maybe we were hitting configured thresholds. We checked API gateway metrics. Throttle count was high, but traffic was within expected limits. That didn't add up. Next thought was sudden traffic burst. We checked request distribution. Traffic was increasing, but gradually, not a spike. Then we looked at concurrent requests. That's where things changed. Concurrency was maxed out. API gateway had a limit, and we were hitting it. Now the question was why? If request rate was normal, why was concurrency so high? We traced request flow. Requests entered the gateway, then took longer than usual to complete. Not failing, just slow, which meant they occupied gateway slots longer. More requests piled up. Concurrency increased. Eventually, new requests were rejected. Now we had a chain. Something was slowing responses, which caused gateway saturation, which caused rejections. We checked backend latency, slight increase, but not enough. Then we looked at a specific endpoint, user profile aggregation. It called multiple services, in sequence, not parallel. Each call added latency. Under load, that compounded. Now multiply that by thousands of requests, each one holding a gateway connection longer than expected. That was enough to hit the limit. The root cause. The issue was not traffic volume, it was request duration. A recent change had introduced additional service calls in a critical path. Instead of parallelizing them, they were executed sequentially. That increased response time per request from around 150 milliseconds to over 800 milliseconds. Individually, that seemed acceptable, but at scale, it increased the number of concurrent in-flight requests. API Gateway has a hard limit on concurrent requests. Once that limit was reached, it started rejecting new ones. Even though back-end systems were capable of handling more, the gateway became the bottleneck. Mitigation and recovery. First step was to reduce request duration. We rolled out a quick patch, parallelized the service calls in the aggregation endpoint. That reduced latency significantly. Then we increased API gateway limits, requested a temporary quota increase, gave us more headroom. Next, we added caching for that endpoint, reduced repeated calls, lowered load further. We monitored concurrency, it dropped. Rejection rate decreased. Users started seeing successful responses again. Full recovery took about 30 minutes. Most of that was deploying and validating fixes. Post-mortem reflection. What failed was not capacity, it was efficiency. We focused on throughput, but ignored concurrency. We assumed small latency increases were harmless, but they compounded under load. Detection was also incomplete. We monitored request rate, but not concurrent request saturation at the gateway. We saw symptoms, but not the underlying constraint. There was also a design oversight, sequential calls in a high-traffic path, without considering their impact on concurrency. Engineering lessons. Concurrency limits are as important as throughput limits. Small increases in latency can have large effects at scale. API gateways can become bottlenecks even when backends are healthy. Critical paths should be optimized for parallel execution. Observability should include in-flight request metrics, not just request rates. And finally, system design must consider how components interact under load, not just how they perform individually. In the end, nothing was overloaded, but something reached its limit, and that was enough.